Hello students, today we are going to discuss something different from what we have been doing since long. Today we will learn that what are the factors which may affect the fringes, interference fringes formed in Young's double slit experiment, and how it affects it, what are the impacts brought on the interference fringes. We shall be discussing them one by one. But before we actually start discussing it, let us recall what was the experimental setup for the Young's double slit experiment. We were having a monochromatic source of light that was made to illuminate two slits which were having some separation of a small d, and due to these two illuminated slits the Young was able to get interference pattern having alternate bright and dark bands produced on the screen, which was placed at d distance from these two slits. Now, and we have also derived the relation for the fringe width is beta equal to capital D lambda by D. Well, I will give you a clue how to keep this formula in your memory. Well, you see, we have 2D, so it is always a matter of confusion that which D is in the numerator and which D is in the denominator. Otherwise, lambda is very much there, which we can have in our memory. So confusing part can be eliminated if you bring in your mind the concept that we start with the capital. So beta equal to capital D lambda by small d. If you think like this, you will never have any confusion starting with the capital. So capital D lambda by d, where we know the meaning of these things. Capital D is the distance of a screen from the slits. Small d is the separation between the two narrow slits, which serves as a coherent source of light. And having these all, we can have the we see the relation beta is equal to fringe width is equal to capital D lambda by small d, where lambda is the wavelength of the light used and beta is the fringe width. So bearing this in your memory, and I believe you have now no problem in memorizing the relation for fringe width. Beta is equal to capital D lambda by d, starting with the capital. So now let us start the main topic, that what are the factors which affects the fringe pattern, interference pattern, if D is increased or decreased nominally. Means if we have the relation beta is equal to lambda D lambda by d, means the relation between fringe width and D is reciprocal. That means when D is increased, beta should decrease. When D is decreased, beta should increase respectively. Now we talk about the second point, the whole setup. The whole setup means this whole experimental arrangement is kept in an optically denser or rarer medium. The whole setup is brought in some another medium which is optically denser from the previous one or optically rarer from the previous medium. Then in that case, what will happen? For that we must understand one basic factor is that whatever be the medium, the frequency of a light never changes. That is the characteristic of the light. Means frequency of the light is the characteristic of light. It never changes whatever be the medium. Only thing which is affected is the speed of light in that medium, and hence the wavelength of light in that medium will be also changed. And the relation for speed, frequency and wavelength is V is equal to nu lambda, and and nu is constant, therefore velocity and lambda will have proportional relation. If the velocity is decreased, lambda will be decreased. If the velocity is increased, lambda will increase. Now when we talk about optically denser medium, it means the light ray is slowing down. and that means the velocity is decreased. If the velocity is decreased, then that means wavelength is decreased. And so if the wavelength is decreased, we have a relation beta is directly proportional to wavelength. So if the wavelength is decreased, the fringe width will be decreased. Now if we talk about a optically rarer medium, in that case the speed of light will increase. If the speed of light increases, then the wavelength of the light will also increase because frequency remains unchanged, and therefore as the wavelength increases, we have the relation beta is equal to d lambda by d. So fringe width is directly proportional to wavelength. If the wavelength increases, then fringe width will increase, and therefore we can say if the whole setup is placed in a denser medium, the fringe width decreases. If the whole setup is placed in a rarer medium, the fringe width increases. Now let us look at the third factor which affects the interference pattern. If D is made infinitely large or infinitesimally small, means the separation between the two slits is increased to infinitely large. In that case, what will happen? If the D is increased infinitely large and we have the relation fringe width beta is inversely proportional to D, and D is increasing infinitely, therefore beta will become infinitesimally small, means fringe width is infinitesimally very small. And when the different thing is happening, means D value is infinitesimally made infinitesimally small, means the two slits are brought very close to each other, the distance of separation between them is negligible, is nearly tending to 0. Then in that case you see fringe width beta is inversely proportional to D, D is tending to 0, therefore fringe width will tend to be infinity. That means fringe width becomes very large. Now we talk about the fourth factor which affects the interference pattern. If the capital D is increased or decreased, means the distance of a screen is increased or distance of a screen from the slit is decreased. Now if we see the relation beta is equal to capital D lambda by D, and therefore we can see that fringe width is directly proportional to capital D, and if D is increased, means separation of distance of the screen from the slit is increased. If D is increased, then fringe width will increase. If D is decreased, then the fringe width will decrease. Now we talk about another factor, if lambda is increased or decreased. Now if the lambda is increased or decreased, it means the monochromatic source of light is sending some light wave. If we change the wavelength of the source, means if we have we use different source of monochromatic light having different wavelength, and it is greater than the previous light used, wavelength is greater, then in that case means lambda is increased, then in that case the fringe width will also increase because fringe width is directly proportional to lambda. And if the wavelength is decreased, means a source used such that it is having a light wavelength smaller than the previous one, then in that case lambda is decreased and therefore fringe width will also decrease because beta is directly proportional to lambda. So in all these cases what you have seen is, if you remember this formula, your conclusions can be very easily derived. You need not mug up the things. Now we talk about the last topic, when monochromatic source of light source is replaced by white light source. Means if the source of light which we have used is was monochromatic, instead of that if we are using a source of white light source, replacing this monochromatic source of light by a white light source, then what will happen? That is the question. Now in this case you have to bear in your mind that the the fringe width for different colors are different, because you see beta is directly proportional to wavelength and wavelength is directly proportional. Wavelength of different colors are different. In white light we have 7 colors VPQ. So they have different frequency, they have different wavelength. The red is having a largest wavelength and violet is having the smallest wavelength. And therefore fringe width for the violet color will be least, because beta is directly proportional to lambda, and fringe width for red will be the widest, and those in between will have fringe width in between these two. This is the basic fact. But one more thing we have to also consider is that all the condition for bright fringe for all the colors will be satisfied at the center. Essentially, whatever may be the color, they all will make this bright fringe at the center. And if all the 7 colors are forming the bright fringe at the center at the same location, then all 7 colors mixing together will bring the impact of white light. Means at the center, the central bright fringe will be formed, which will be white in color. And apart from this, nowhere we will have the white color, because of the fact that the different colors of light will have different fringe width. So the next one, the first bright fringe after the center, means the bright fringe just after enveloping the central bright fringe, that will have these fringes for different colors will have different thickness, and therefore their location of formation of the first bright fringe will be different for different colors. So the central bright fringe, which will appear white, will be enveloped by the blue bright fringe. Why we say blue? Now we have violet and indigo already there. They should be much closer to the central bright fringe as compared to that of the blue, but blue brings greatest impact on our eye, and so it will dominate the indigo and violet colors. Therefore the two enveloping bright fringe, the central bright fringe will be enveloped by blue pattern, that followed by green and red. So beyond that, once this pattern observed, beyond that all the other patterns will be repeated and they will overlap each other, and as a result we don't have any clear fringe color formed and observed. So that's all for today. I believe that whatever numerical problem you get on this topic, Young's double slit experiment, I believe that you will be able to solve it without any problem. Only thing you have to remember is B is equal to D, capital D lambda by small d. Which one should be in the numerator, because we start with capital, so you remember this fact and it will help you a lot. That's all for today. Thank you and have a nice day.